Welcome back to AI Tech Zone. Today, we're diving deep into a fascinating topic that's at the core of how neural networks function and learn: activation functions. By the end of this video, you'll have a clear understanding of what activation functions are, why they're crucial, and how they shape the capabilities of AI systems. Before we get started, don't forget to hit that subscribe button so you never miss out on our latest tech insights. Alright, let's kick things off with a quick question. Have you ever wondered how neural networks decide which information is important and which isn't? It all comes down to activation functions. Intrigued? Stick around as we unravel this mystery. So, what exactly are activation functions? In simple terms, an activation function determines whether a neuron in a neural network should be activated or not. Think of it like a gatekeeper deciding which information should pass through and which should be ignored. Imagine you're at a concert and the activation function is like the security guard at the entrance. Only people with valid tickets, relevant information, are allowed in, while the rest are kept out. Now, why are activation functions so important? They introduce nonlinearity into the model, which allows neural networks to learn complex patterns and make sophisticated decisions. Without them, the network would simply be a linear model, severely limiting its capabilities. For instance, without activation functions, a neural network trying to distinguish between cats and dogs would fail miserably. It would just draw a straight line, unable to capture the intricate differences between these animals. Let's explore some of the most commonly used activation functions and understand how they work. We'll look at three main types: Sigmoid, Tanh, and ReLU. First up, the Sigmoid function. It squashes input values to a range between 0 and 1, making it useful for binary classification problems. Imagine trying to predict whether an email is spam or not. The Sigmoid function helps by providing a probability score, indicating the likelihood of the email being spam. Next, we have the Tanh function. It scales input values to a range between -1 and 1, which can be beneficial for hidden layers in a neural network. Example for Tanh. Think of it as a thermostat that adjusts the temperature both up and down, providing a more balanced output. It's particularly useful when the network needs to model negative and positive values symmetrically. Subsection 3.3, ReLU function. Finally, the ReLU, rectified linear unit function. It's one of the most popular activation functions due to its simplicity and effectiveness. ReLU outputs the input directly if it's positive, otherwise it returns 0. Example 5. ReLU. Picture this as a bouncer at a club. If you're above a certain age, positive input, you're allowed in. If not, you're kept out. This helps in preventing the vanishing gradient problem and speeding up the learning process. But wait, there's more. Beyond these basics, there are advanced activation functions like Leaky ReLU, ELU, and Swish, each with its unique benefits. Leaky ReLU addresses the issue of dead neurons in standard ReLU by allowing a small, non-zero gradient when the input is negative. Imagine a scenario where even the underage guests or negative inputs can still peek into the club through a small gap in the door, gaining some influence. ELU, or exponential linear unit, goes a step further by smoothing out the curve for negative inputs, leading to faster and more robust learning. Think of it like a VIP pass that allows negative values to enter but with a lesser impact, ensuring smoother operation. Swish, a newer activation function proposed by Google, combines the best of both worlds from Sigmoid and ReLU, providing better performance in many cases. Example 8. Swish. It's like having an AI-driven security system that adapts based on the crowd, offering optimal results. Section 5. Choosing the right activation function. Choosing the right activation function depends on the specific problem you're tackling. While ReLU is a go-to for many deep learning tasks, sometimes experimenting with other functions like Swish or ELU can yield better results. For instance, in an image recognition task, ReLU might work wonders, but for a complex time series prediction, Tanh or Swish could be more effective. And there you have it. Activation functions are the unsung heroes that empower neural networks to perform complex tasks. By understanding their roles and choosing the right ones, we can unlock the full potential of AI. If you enjoyed this deep dive into activation functions, make sure to like, comment, and subscribe to AI Tech Zone. Let us know in the comments which activation function you find most intriguing, or if you have any questions. Don't forget to hit the notification bell so you never miss an update. Thanks for watching and see you next time with more exciting tech content.